you everybody who is watching this video? My name is Olenjolai from United Republic of Tanzania. I would like to welcome you into our online school that called Tanzania Online Advanced Secondary School in square bracket Olenjolaim. And we have a YouTube channel also called Tanzania Online A-Level City Schools in square bracket Olenjolaim, where that we used to upload several videos to train and teach A-Level students. Remember that the vision for our online programs is we want to incubate and teach students how they can take their classroom instructions and combine their spiritual knowledge in order to solve real life problems. So we have a good news today that we have one of our physical students who have been attending our programs physically for some months right now. And you know that in every session I used to leave a homework for students to try. So even if that I used to have him, he used to take that questions and then we'll spend some time and do it and come back with the feedback that whether he has succeeded to get a right answer or not. So well enough, this is the one of example because we are in departments of advanced physics and the subject is advanced physics and the main topic is electrostatic, and this is the material for Form 5 or Class 13, so Form 6 or Class 14. And we had a session, so we want to make a correction, we want to do the corrections of homework 4, which is example 3, which is this one, example 3. And it has been told that, oh, I left it in session 4. Okay? So I left it in session 4. And so this is the question. We wrote it on the blackboard, so to remind you, it's a kind of the conceptual questions. We wrote it's a concept. And the questions read that the two small spheres, each having mass of 0.1 grams, are suspended by the threads of 20 centimeters long. They are equally charged and they repel each other to a distance of 24 centimeters. What is the charge on each sphere? So I left these questions to every student, right? Every student who is going to check these contents of electrostatic. So I said that one students want to do just to encourage online students, because once you do these questions, you have to submit your solution in the comment sections below here. You click the comment sections, then you submit your homework. So one of the students is going to encourage, I'd like to invite one of my students to do these questions from the beginnings to the end, and also to give you feedback that how students understand, to give you courage, and even this, take as a challenge. If you're students who are watching this video, take as a challenge that even yourself, you can do all the homeworks questions that have been left in each sessions. And the main purpose is to help you to understand what is going on through. Okay? So I'd like to welcome right now, don't want to stay too much. Let me invite the student and then I'll leave him on the blackboard to work on behalf. So this is one of my students. His name is Joshua Msuya. He's a Form 5 student doing his studies at Mzombe Secondary Schools in the combinations of PCB, means physics, chemistry, and biology. So he's one of my physics students. So welcome, Mr. Joshua. Online students are listening to you, so you can greet them and then you can go to business.
Okay. Hi everybody, my name is Joshua Msuya, as Mr. said. I'm a Form 5 student taking a combination of PCB at Mzombe Secondary School. I love physics and I would like to ask you to love physics. As I was solving this question, because I attended the physical class and the teacher left this homework, as I was solving, I got it right and I asked God, can you help me so as I may go to solve in front of the mass? And the time has reached now. Let me go to show you the business. Welcome.
Okay, all the best.
Okay. So this is example 3. It is a correction of homework 4, example 3. Two small spheres, the question says, two small spheres, each having a mass of 0.1 gram, are suspended by a thread of 20 centimeters long. They are equally charged and they repel each other to a distance of 24 centimeters. What is the charge on each sphere? So, according to how I was taught by Honorable Mr. Olenjolai, the man taught me to solve this question in stepwise. So we have to go in step number 1. Are you together? Step number 1. First step. So the first step, usually we have to recall data given. So from our question, we are given two small spheres, each having the mass of 0.1, mass of each sphere. In bracket M is equal to 0.1 gram. They are suspended by a thread of 12 centimeters long. That means this is length of the thread. L is equal to 20 centimeters. They are equally charged and they repel each other to a distance of 24 centimeters. So this is distance of separation. The distance of separation in bracket D is equal to 24 centimeters. What is the charge on each sphere? So charge on so again, for better clarification of this question, I have to represent this given data diagrammatically. I have to sketch the problem. Sketch so this is the point where they are held. And the two charges, this is the first and this one is the second. This is the medium, which simply because we are not given the medium, so I term the medium as air. And the distance from here to here, it is 24 centimeters. The distance, this one are the thread where the two charges are suspended. This one it is same as this one. So we are given the charges we are told that are equal. So I term them as positive Q and this one positive Q. So from here, the first another step that is coming, we have to split this 24 centimeter into 12 and 12 because for the purpose of getting this angle, because here there is an angle which is angle theta. Theta and here theta. So in order to get it, I have to split this 24 into 2 equal 12 so as I may get the angle by using trigonometric stations. Thereafter, a diagram will then be like this. So this is the diagram. These are the point charges. So here it is 12 centimeter, and here 12 centimeter. Here it is 20 centimeter, and this one is angle theta, theta, and here theta. So The third step, recall. You have to recall trigonometric stations. Recall that we are given an angle with the adjacent and the hypotenuse. So the suitable trigonometric station to use here, it is cosine. Cos theta is equal to adjacent over hypotenuse, which is then equal to 12 centimeter over 20 centimeter. Centimeter and centimeter cancel. 12 divided by 12, so cos theta is equal to 0.6. As I said before, the purpose of me applying trigonometric station is in order to get the value of theta. So I have to find the inverse of this cosine of theta so as I may get the value of theta, angle. Theta is then equal to cos 0.6. The value of theta is equal to take your scientific calculator like this mine here. You have to press shift cos, open your bracket, 0.6. The value of theta is, so theta is equal to 53.13 degree. Are we together? So from there again, what are we going to do? We're going in the fourth step. Simply because we have already known the value of theta, we have to resolve the forces into the respective horizontal and the vertical component. So the first step, again I have to draw my diagram here. This one are the point charges. So in order to get the value of vertical component, I have to take, and this one is the force, electrostatic force on the charges. So for horizontal component, cosine of theta is equal to fx over f. That is, the value of fx is equal to f cos theta. So this is the first equation. Do you enjoy physics? Okay. Then for vertical component, sin theta is equal to Fy over F. So the value of Fy is equal to F sin theta. This is the second equation. So again, you have to read the question. We are told that these charges, they are equally charged. That means even their forces, they are at equilibrium. So the fifth step, we are in the fifth step again. If the forces are at equilibrium, then before going there, we have to come on this diagram here. In this charge 1, it has its own weight, which is going downward. Also, this one is the force on charge 1, and here it is the electrostatic force or the vertical component, and this one is the horizontal component, which is going in this direction. Also, charge 2, because we are told that to find the charge on each sphere, this one is the vertical component, this one is the electrostatic force on charge 2, and this it is the horizontal component. Same applied, this is the weight of the charge. So simply because the charges, the sphere are equally charged, then at equilibrium, horizontal component Fy is equal to force sin theta is equal to mg. Are we together? So this one is the third equation. Are we together? So again, we have to consider the horizontal component is equal to force cosine of theta, which is then equal to the force, the electrostatic force on charge. This is the first equation. So we have to develop a relationship from these two equations. How do you think, which relationship are we going to develop? For me, how I think, fixed step, divide equation 3 by equation 4. Physics is wonderful. The way I solved it on my exercise is different from the way I'm solving right now here. So, divide equation 3 by equation 4. Equation 3, force of sin theta over F cos theta is equal to mg over force on charge. This force and force cancel. So sine of theta over cosine of theta is equal to mg over f. But we all know sine of theta over cos of theta is equal to tan theta. So tan theta is equal to mg over f. We have to make the force the subject. Force is equal to mg over are we together? If I'm going rush, please pause the video, then solve the question. Physics is sweet, physics is wonderful. You have to compute the, seventh step. Compute for F. F is equal to mg. The mass we are given is 0.1 gram, which is equal to 0.1 exponent negative 3 kilogram times acceleration due to gravity, which is 9.8 meter per second square, over tangent of 53.13 degree. So take your scientific calculator like this one. Tangent of 53.13, then 0.1 exponent negative 3 times 9.81 divided by my answer. I get the force of attraction or repulsion is so this is the value of the force. Again from here, so simply because we have already get the force, we are approaching the end of this question. From here, we have to recall our best formula, which is Coulomb's electrostatic law, which is the 8th step. Recall Coulomb's law of electrostatic. According to Coulomb, this man said that the force of attraction or repulsion is directly proportional to the product of the charges and inversely proportional to the square of the mean distance between them. So, force of attraction or repulsion is directly proportional to the product of the charges over the square of the mean distance between them, which is then equal, after removing the proportionality constant by adding the constant k and the equal sign, F is equal to k q1 q2 over r squared. So from here again we have to compute for the value of k. 9th step, compute k. Then from we are told that K is equal to 1 over 4 pi times epsilon 0 O. So the value of epsilon 0 is equal to 8. It is the constant. Look on your scientific calculator, constant 32, this one, is equal to 8.85 exponent negative 12. The bad effect of scientific calculator, it does not give you the SI unit. Then K is equal to 1 over 4 pi times 8.85 exponent negative 12. So times 4 times shift pi, and then inverse of my answer. I get the value of K is approximately to 9 exponent 9. So substitute the value of K into the Coulomb's equation of electrostatic. Coulomb's equation of electrostatic. Then force is equal to K Q1 Q2 over R squared. But from your question, you are told that the value of Q1, the two small spheres have equal charges. That means Q1 is equal to Q2 is then equal to Q. Do you enjoy? So force is then equal to K Q square over R square. I'm approaching the end of this question. So after here I have to make Q the subject to the formula. F R square over K is then equal to Q square. Introduce square root both sides. Then Q is equal to F R square over K. Believe me, physics is sweet, physics is simple if you solve many different questions. And the bad effect of physics, different questions and different concepts are hidden on the question. So if you don't solve questions, you won't see the concept. Then Q is equal to the value of force of electrostatic is equal to 7.35 exponent negative 4 times square of the radius. It is 24. We were given 24 centimeter. You have to convert them into the system international unit, that is 24 exponent negative 2 square over K, which is 9 exponent 9. So from here is then the matter of computation. Nine exponent 9 is equal to 7.35 exponent negative 4 times 24 square. So the value of charge is equal to let me compute here. 7.35 exponent negative 4 times 24 exponent negative 2 square divide by 9 exponent 9 under root of my answer. Q is equal to 6.858 exponent negative 8 Coulomb. Again, we have to represent our answer in microcoulomb. We know that 1 coulomb is equal to exponent negative 6 microcoulomb. So Q is equal to 6.5. So recall one coulomb is equal to
1 coulomb.
1 coulomb is equal to so
1 coulomb is equal to what?
1 exponent 6 microcoulomb. So the value of charge is equal to 6.858 exponent negative 2 microcoulomb. So therefore the value of charge on each sphere is 6.858 exponent negative 2 microcoulomb. So up to now, this is the end of the question. I thank God who has been with me from the time I was solving, from the first up to this, the end. So I would like to ask you to solve many questions relating on this concept, not only electrostatic but also mechanics. You see, this question comprises of different concepts of mechanics. So in some of the conceptual questions, I would like to ask you to solve different questions on different topics in order to be more competent for future, for the betterment of yourself, for the betterment of your life and your future coming life. Thank you.
Okay, so before you leave, I think that's a good moment. We have to clap the hands. Everybody who is here and who are online. So let us congratulate Mr. Joshua. Okay? So congratulations, Mr. Joshua. You have been doing a great job actually, and I think that you have tested what the great business are used to do in the blackboard, because you have done 1 questions, but it might be seem like more than 10 questions.
Yeah.
Okay. So thank you very much for watching, and thank you very much for listening. One of my beloved students, and I believe that you have got something. In case you have any questions concerned about what he has been presenting, you can ask in the comment sections. So don't hesitate yourself to ask in the comment section. So this is why did I do this? Okay, the main objective to let the students to solve the questions in the blackboard. I want just to tell the world, and especially the Tanzanians, that it's possible. You can solve even problems, regardless that whether you're a teacher or you're not a teacher. But the issue is you can solve those problems, whether the classroom problems or problems originating from textbooks or any questions and answers book. So this is the encouragement that even yourself who is watching right now, you can solve more questions as well as you can. Regardless whether you are a class teacher solving problems or just teaching a concept, don't spend your time and waste your time on complaining. This is the right time. You see a student, yes, he took the online program, and then however that he was being physically there, but he did this too much of revisions on what I taught, because we used to record this stuff. So he has been going through and understanding the concept around so that he can solve different questions. So I thank you very much for taking your time. I think that the next thing I would like to be that the next might be you who is watching right now. You can come and dance, you can be enjoying on solving the question on behalf of others. Because these solutions will be kept for the present and future generations, and they will enjoy it. Actually, that the work of Joshua, actually that will be well remembered and even encouraging some other students, because myself, I did my A-level studies more than 11 years ago. So for this guy, at this moment, he's doing the A-level studies. So we brought a practical, because we are teaching science and mathematics, those are the practical subjects. So these sessions, there's been a practical session. So make sure that you solve many questions as well as you can, and solve those homework questions, and see you in the next sessions. May God bless you. See you again.